So see, good afternoon to one and all. In the previous lecture, we have discussed regarding speed control of DC shunt motor. In that, we have discussed regarding speed control of DC shunt motor in that Ward-Leonard system. That is voltage control method. In that, there are two types. That is, first one is nothing but multiple voltage control method, and second one it is nothing but Ward-Leonard system, right? So this Ward-Leonard system of speed control we have already discussed in the previous lecture. Now today we will discuss about the next one point or next one speed control by DC series motor. That is speed control method or the speed control technique of a DC series motor. So see, in that speed control technique, again according to equation, N is directly proportional to EB divided by phi. So either we are controlling the speed of DC series motor by controlling the armature voltage, that is EB, and by controlling the flux produced by series field winding, so that is phi. So see, there are some methods to control the speed of DC series motor. The speed control of DC series motor can be obtained by using a flux control method, and second one is that the armature control method. That means by controlling the armature voltage, we are able to control the speed of DC series motor, and by controlling the flux produced by series field winding, we are able to control the speed of DC series motor, right? So these are the two techniques according to equation. Here it is proved. Now see, in case of flux control method, you people already know the flux control is nothing but we want to vary the value of flux. Flux ची जी काही value आहे, that means flux produced by the machine, we are just varying this quantity of flux. That is, hence the resultant value of flux it will be changes, and if the resultant value of flux it will be changes, then there is a change in the speed of DC series motor. DC series motor च्या speed मध्ये काय होतो, change होतो. Now see, in this method, the flux produced by series motor, the flux produced by series motor, flux produced by the series motor, it can be varied. Then the speed of DC series motor, it can be varied according to equation. So you people know according to the equation, that is N is directly proportional to, or I am writing here equation, that is N, it can be directly proportional to EB divided by phi. So see, N, it can be directly proportional to the EB divided by phi. N is directly proportional to EB divided by phi. If we maintain the back EMF of the machine, it will be constant. Then your equation N is directly proportional to 1 upon phi. So by varying the value of this flux, we are able to change the speed of DC series motor, right? So see, in this method, the flux produced by the series motor, it will be varied, and hence the speed of DC series motor it will be varied. Okay, जसे आपण flux control करू, so similar to that, if the flux it can be controlled or flux it can be changed, then the speed of DC series motor it will be changed. Now see, this flux variation or this change in the flux, it can be done by using some of the method. हे जे काय flux change करतोय आपण, so this flux it can be changed by using, there are some method, that means there are two method. In that, first one is nothing but field diverter. Okay, so this method it is nothing but field diverter technique, or another one is nothing but the flux control technique. So we will see one by one. That is, as you people know that in case of series motor, the series field winding it is in series with that of armature. So I will draw the diagram for that. Otherwise I will show the diagram. Okay, see, in case of DC series motor, suppose this is the field winding of the series motor, and this one is the armature of the DC series motor, right? And here we are able to provide a voltage, or it may be supply is given to that of machine. See, in case of series motor, the field winding of the motor, it is connected in series with that of armature. ती काय केले आर्मेचरच्या सीरीज मध्ये कनेक्ट केले. So see, so supply current as well as series field winding current as well as armature current, whether it is same or different, that means IA, ISE and supply current, or we can call it as a load current, whether it is same or different in case of series motor.
Same.
That means IA it is equals to ISC, it is equals to IL. Okay. So see, if we want to change the flux produced by this series field winding, what we want to do? काय करावं लागेल आपल्याला?
Current change.
म्हणजे याच्यामधून फ्लो होणारा करंट मला चेंज करायचा आहे. What we want to do?
Resistance increase.
We want to connect resistance in case of previous method. Previous method मध्ये आपण बघितलं आपण काय करतो त्याच्या सीरीज मध्ये रेजिस्टन्स कनेक्ट करतो. Suppose see here, if I connect one resistance in series with that of field winding, so this resistance in series with that of field winding as well as armature winding, हा जो काय रेजिस्टन्स आहे तो आर्मेचर वाइंडिंग प्लस सीरीज फील्ड वाइंडिंगच्या सीरीज मध्ये आहे ना?
Yes, sir.
Okay, see, if I increase the resistance, that means current flowing from series field winding it will be reduces. At the same time, current flowing from armature it will be also reduces. At the same time, supply current taken by the machine it will also reduces. All current reduce होता है ना?
Yes, sir.
Okay. So see, if we are decreasing the value of flux, at the same time the armature current it will be decreases. If the armature current it will be decreases, according to this IA RA drop it will be decreases, again it will maintain the speed same, so that this connection of series field winding, that is connection of one resistor, that is variable resistor, in a series with that of armature as well as field winding, it is not suitable in case of DC series motor speed control. So that there are another two technique it can be used to control the flux produced by series field winding. In that, first one the armature diverter, and the second one is that the first one is nothing but field diverter and the second one is nothing but armature diverter. म्हणजे बघा, what is mean by diverter? Can anyone? What is mean by diverter? सांगितलं ना मी meaning पाठीमागच्या लेक्चरला. That is meaning of diverter. So we are constructing one of the another way to flow the current. It is nothing but diversion. As simply we are telling the example of that of when the road it is in construction, there is one of the diversion way. Okay, that means diverter it is nothing but we are constructing one of the another way to flow the current. See, in case of field diverter, so first one technique je ahe we are discussing regarding first one technique, that is field diverter. See, in case of field diverter, we are just connecting one of the resistance in parallel with that of field. Field च्या parallel मध्ये काय करतोय आपण? एक resistance connect करतोय. We are connecting one of the resistance. It is in parallel with that of series field winding. Just 1 minute. Okay. See, we are connecting one of the resistance. It is in parallel with that of field winding. That means we are constructing another way to flow the current. Now see, I want to change the flux produced by field winding. Suppose here we are diverter. Meaning of diverter is nothing but we are constructing one another way to pass the current or to flow the current. In this method, the variable resistance, it is called as field diverter, is connected in parallel with series field winding. Series field winding च्या parallel मध्ये आपण काय करतोय? variable resistance connect करतोय, so we can call it as a field diverter. So it is nothing but field diverter, or it nothing but one variable resistance. It can be connected in a series with that field winding. Okay. Now what effect can be done? See, suppose we are supplying a 10 ampere current to the machine. Machine ला मी काय करतोय, 10 ampere current flow करतो. If this diverter it cannot be used, जर हा diverter use केलेला नसेल, all 10 ampere current flowing from this series field winding, right?
Yes, sir.
If we are not constructing a diverter, same current it will be flowing from armature. That means 10 ampere it will be flowing from armature. Armature मधून पण किती 10 ampere current काय होतोय, flow होतोय. Now see what happen if diverter it can be connected. We want to change, our motto is that we want to change the flux produced by this field winding. Field winding न produce होणारे flux काय करायचे मला change करायचे. Either we want to increase or it may be decrease. Suppose I am connecting one of the variable resistance in parallel with that of field winding. Field winding च्या parallel मध्ये काय करतोय मी एक resistance connect करतोय. Suppose initially the resistance having an value of maximum position. Resistance हा काय आहे, maximum मी काय करतोय add करतोय. That means resistance is at maximum position. When the resistance is at maximum position, that means minimum current flowing from this line, right?
Yes, sir.
होणारा करंट काय असेल, मिनिमम असेल. सपोज कन्सिडर इनिशियली दिस रेजिस्टन्स हॅव्हिंग अन मॅक्सिमम व्हॅल्यू, झिरो करंट इट विल बी फ्लोइंग फ्रॉम दिस लाईन अँड टोटल करंट फ्लोइंग फ्रॉम दिस लाईन. इफ आय रिड्यूस द व्हॅल्यू ऑफ दिस रेजिस्टन्स, या रेजिस्टन्सची व्हॅल्यू काय केली, रिड्यूस केली. व्हॉट हॅपन इफ द रेजिस्टन्स व्हॅल्यू इट कॅन बी रिड्यूसेस? व्हॉट अबाउट करंट?
Increasing.
Current flowing from that winding it will be increases. See, suppose current flowing from that is nothing but 2 ampere. याच्यामधून फ्लो होणारा करंट काय आहे, 2 ampere आहे. या कंडिशनला आपण कन्सिडर केलं. Now see, total supply current is nothing but 10 ampere and the current flowing from this diverter path is nothing but 2 ampere. What is the current flowing from this line? 8 ampere. That means according to KCL, this current it will be divided into two way. One is current flowing from the field diverter and another current it will be flowing from field winding. Okay. Now see the 8 ampere current flowing from this field winding. Now see total current flowing from the armature. Armature मधून flow होणारा total current किती असेल? So see 2 ampere flowing from this diverter, 8 ampere flowing from this field winding. So total current flowing from this armature. Armature मधून flow होणारा current
10 ampere.
10 ampere. Again it is same. Okay. See, supply current is equals to it is equals to armature current and it is not equal to that of field current. बरोबर? म्हणजे हे रिलेशन येते का इथं? That is IA is equals to IL येईल, but it is not equal to ISC, right? बरोबर?
Yes, sir.
That means we are changing the current flowing from field only. फील्ड मधून फ्लो होणारा करंट काय करतोय, चेंज करतोय, राइट? बरोबर?
Yes, sir.
If the current flowing from this field winding it will be changed or current flowing from field winding it will be vary. What about flux? What about phi? Suppose current flowing from this is nothing but it is decreased from 10 to 8. 10 पासून 8 पर्यंत तो काय झाला, कमी झाला. That means 8 ampere current flowing from this field winding. What about flux?
Flux decreases.
Flux it is also decreases. And if the flux decreases, according to relation, N is directly proportional to 1 upon phi or it may be EB upon phi. If the phi decreases, the speed of the motor it will be increases, right? And similar way, suppose we are keeping this as a minimum position. याच्या opposite आता जर हे मी काय केलं, suppose 10 ampere flowing from line, if I kept this variable resistance at the minimum value, ज्यावेळेस मी minimum value ला kept करतोय, that means maximum current it will be flowing from this line and the flux produced by this field winding it is nothing but suppose 2 ampere flowing from field winding, 8 ampere flowing from this side. At that situation 2 ampere current it will produce some amount of flux, that is phi 1 flux. And when I vary this resistance which are connected in parallel with that of series field winding. Suppose I am increasing resistance. If the resistance increases, the current flowing from that is nothing but whether it is decreases or increases.
Decreases.
Decreases. Suppose current flowing from this is nothing but 6. Decrease zala. Now total current 10, 6 ampere flowing from this line. So 4 ampere flowing from this line. If the current flowing from field winding, it will be increases. That is current ISC, it will be increases. What about phi? As compared to initial phi?
Increases.
Increases. If the phi increases, according to relation, n is directly proportional to 1 upon phi. If the phi increases, the speed of the motor, it will be decreases. So that's way we are able to control the speed of DC series motor by connecting one of the field diverter. So all of you keep in mind, meaning of diverter is nothing but instead of connecting resistance in series with that field, we are connecting resistance in parallel with that of field. Okay, diverter or diversion, meaning of that हा रोड आहे असं कन्सिडर करा आणि मी डायव्हर्जन म्हणतोय. डायव्हर्जन ऑन दिस साइड, दॅट मीन्स पॅरलल टू दिस लाइन we are constructing one another way. So it is nothing but resistance, it can be connected in a parallel with that of field winding or across the field winding, right? So see, we will see here in this method a variable resistance, we can call it as a field diverter. It is connected in parallel with series field winding as shown in figure. Its effect is shunt some portion of the line current. काही पोर्शन लाईन करंटचा काय करायचा, शंट पाथ मधून फ्लो झाला पाहिजे. दॅट मीन्स वी आर विकनिंग द व्हॅल्यू ऑफ फील्ड ऑर इन्क्रीजिंग द स्पीड. स्पीड इन्क्रीज करू शकतो बाय विकनिंग द व्हॅल्यू ऑफ फ्लक्स. ओके, सो द लोवेस्ट स्पीड ऑब्टेनेबल इज दॅट करस्पॉन्डिंग टू द झिरो करंट इन द डायव्हर्टर. ज्यावेळेस झिरो करंट डायव्हर्टर मधून फ्लो होईल, at that situation total current flowing from this field winding, so at that situation we are obtaining the lowest speed or it may be minimum speed. Okay, now obviously the lowest speed obtainable is the normal speed of the motor. Consequently this method can only provide speed above the normal speed. So this method ji ahe, it can only provide the speed above the normal speed. And this field diverter technique, I am telling one application here. This field diverter technique, it is employed in case of traction work or it may be electrical traction. Traction work मध्ये आपल्याला जे काही ट्रेनचं स्पीड चेंज करायचे, so for that reason we are able to use this field diverter technique. So in case of application of series motor, I have tell that due to high starting torque, the series motor it is used in the traction work application. And speed control technique for that traction work application, it is used field diverter technique. Okay, another technique is nothing but armature diverter, and another one technique is nothing but tapped field control. We will discuss next. All of you understood this field diverter technique? हे लक्षात आलं का? Okay, just diverting or just paralleling to that of field. Now second one technique, it is nothing but armature diverter. What is mean by armature diverter? Can anyone tell me meaning of armature diverter? What is the meaning of diverter? Meaning of diverter?
One extra path.
Okay, we are constructing one extra path. आर्मेचर डायव्हर्टर म्हणजे आर्मेचर करंट जो आहे तो करंट डिवाइड करण्यासाठी एक आपण एक्स्ट्रा पाथ फ्लो करतोय किंवा एक्स्ट्रा पाथ कन्स्ट्रक्ट करतोय. दॅट मीन्स वन ऑफ द व्हेरिएबल रेजिस्टन्स इट कॅन बी कनेक्टेड इन पॅरलल विथ दॅट ऑफ आर्मेचर. आपण कशाच्या पॅरलल मध्ये कनेक्ट करतोय? आर्मेचरचे. सो सी, इन ऑर्डर टू ऑब्टेन स्पीड बिलो द नॉर्मल स्पीड, अ व्हेरिएबल रेजिस्टन्स कॉल्ड आर्मेचर डायव्हर्टर is connected in parallel with that of armature as shown in figure. See, here it is series motor. This is the armature of the machine. This one is the field winding of the motor, and here it is supply. It can be provided to that of machine. Machine ला काय केलंय? Supply provide केलंय. One of the variable resistor or it may be one diverter. It can be connected in parallel with that of field winding, sorry, in parallel with that of armature. आर्मेचरच्या पॅरल मध्ये काय केलेलं आहे आपण, एक डायव्हर्टर किंवा एक व्हेरिएबल रेजिस्टन्स काय करतोय, कनेक्ट करतोय. नाउ सी द डायव्हर्टर शंट्स द some current that is some line current which are flowing from that of armature. It will shunt by that of diverter. ओके, डायव्हर्टर काय करेल, काही अमाऊंटचा करंट काय करेल, शंट करेल किंवा तो दुसऱ्या लाईन मधून फ्लो होईल. So if it will shunt this current, then the current flowing from armature, whether it is change or not, armature मधून फ्लो होणारा करंट चेंज होईल का नाही?
Yes, yes.
चेंज होणार ना. See, suppose 10 ampere current flowing from this line, suppose IL is equals to 10 ampere. Same current it will be flowing from series field winding, right? ISC current किती असेल? Series same असेल. Okay, now see, we are changing the current flowing from that armature. Armature मधून फ्लो होणारा करंट काय करतोय, चेंज करतोय. That means we are just connecting one of the variable resistance in a parallel with that of armature. Now see, if the current flowing from this series field winding and the current flowing from this supply, if it is equal, what about value of flux? Or it may be constant. What about value of flux? Flux ची व्हॅल्यू काय होईल? याच्यामधून फ्लो होणारा करंट कॉन्स्टंट आहे, सो दॅट फ्लक्स रिमेन्स कॉन्स्टंट, राइट? नो, बरोबर?
Yes, sir.
Okay, now see equation, En is directly proportional to Eb divided by phi. If the phi is constant, that means En is directly proportional to Eb. Again, what is Eb? Eb is nothing but En is directly proportional to V minus Ia Ra. It is nothing but Eb. Now see, suppose 10 ampere current flowing from this, same current it will be flowing from field winding, and we are inserting some of the variable resistance. Suppose at the value of suppose initially the resistance having a maximum value, at that situation total current flowing from armature. If I reduce the value of resistance, suppose if I reduce the value of resistance, that means some current it will be flowing from this diverter. Suppose 2 ampere flowing from this diverter, 8 ampere flowing from this field winding. What happen if the current flowing from armature, it will be changed. आर्मेचर मधून फ्लो होणारा करंट काय झाला, रिड्यूस झाला. काय होईल? व्हॉट हॅपन? बघा या इक्वेशन वरून. सो दिस इज द प्रूफ. En इज डायरेक्टली प्रोपोर्शनल टू V मायनस IARA. सप्लाय व्होल्टेज सेम आहे, करंट काय होतोय, हा चेंज होतोय. दॅट मीन्स द करंट फ्लोइंग फ्रॉम आर्मेचर इट विल बी रिड्यूसेस. आर्मेचर मधून फ्लो होणारा करंट काय झाला, रिड्यूस झाला. इनिशियली 10 होता, परत तो रिड्यूस झाला. दॅट मीन्स इट विल बी रिड्यूसेस. इट इज नथिंग बट 8 एम्पियर. व्हॉट हॅपन? काय होईल?
Speed increases.
डायरेक्टली स्पीड इन्क्रीजेस. काय होईल?
फ्लक्स इन्क्रीज होणार.
फ्लक्स इन्क्रीज होणार.
रिपीट करत.
Okay, see, if the current flowing from armature, it will be decreases. What happen? First effect,
Flux also decreases.
फ्लक्स ऑल्सो डिक्रीजेस. कुठे येतोय? तर फ्लक्सचा पार्ट येत नाही. फ्लक्स मधून फ्लो होणारा करंट 10 एम्पियर सेम आहे. दॅट मीन्स वी आर मेंटेनिंग फ्लक्स phi is constant. I am written this equation only. So see, current flowing from this Ia, it will be reduces. This drop, it will be reduces. This drop, it will be reduces. That means V minus IRA हा जर व्हॅल्यू रिड्यूस झाली, काय होईल? स्पीड इज ऑल्सो रिड्यूसेस, राइट? So see, the diverter shunt the some line current, thus reducing the armature current armature current काय will reduce will. Now for given load, given value of load, if the IA it will be decreases. दिलेल्या value of load ला IA decreases, flux phi must be increases according to this equation. That is torque equation. What is the torque equation? T is directly proportional to phi into IA. Okay. So see, if IA it will be reduces, there is a change in flux also. That means if the IA reduces, according to the current taken by the supply, it will be also reduces. If the current taken from the supply, it will be reduces. The flux produced by field winding, it will be reduces. Again, En is directly proportional to 1/5, and also En is directly proportional to EB. The speed of the motor it will be decreases. Motor's speed काय will decrease will. किंवा या relation वरून speed of the motor it will be decreases. Now see, by adjusting the armature diverter, the speed any lower than speed it can be obtained. By adjusting the field diverter, we are able to obtain the speed below to that of rated speed, or the any speed lower than that of rated speed. Rated speed च्या lower speed आपण काय करू शकतो, obtain करू शकतो. Okay, so this is one technique related to speed control, that is armature diverter. Okay, armature diverter. Now see, next one technique, that is tapped field control. Tapped field control. Can anyone tell me what is mean by what is the meaning of tap, or it may be tapping? Meaning of tapping सांगितलं होतं ना मी. Just connecting any particular point, or it may be in any one of the terminal, किंवा एखादी लाइन आहे consider करा. So suppose this is one single phase line. I am tapping here. Tapping is nothing but taking one point, or it may be terminal. म्हणजे आपण जनरली लाइन वरती आकडा टाकतो. It is called as tapping in our language. So tapping is nothing but we connecting that particular point to get the connection. Now see, tapped series field winding, tapped field control, or it may be tapped series field winding. See, so in case of tapped series field winding, we are constructing some of the tapped terminal, or it may be some tapping to that of field winding. Suppose consider this is one of the series field winding. मोटरची डायरेक्शन मोटरची डायग्राम तुम्हाला माहित आहे. Suppose this is the series field winding. This one is the armature of the motor. Okay, and here it is supply voltage, it can be provided. Supply voltage it can be provided. Now see, meaning of tapping or meaning of tapped. So see, this field winding it can be tapped for a particular point, or it can be divided into some tapping point. Tapping point ला ते काय केलं असेल, divide केलं. Suppose this is nothing but having a number of turns 100. This 100 number of turns it can be divided into 4 part. हे जर आपण 4 part मध्ये divide केले, that means 25 number of turns for the first tapping. Suppose मी टॅप म्हणजे एक टर्मिनल घेतो, इथे एक टॅपिंग केलेलं असेल. एक टॅप्ड पॉइंट इज गिवन 0 to 25. Second tapping point it is nothing but, suppose this is here it is 0 to 50. Then here it is 75, and he total connected असेल 100, right? That means the field winding it is tapped at a particular point. किंवा field winding some terminals are taken out for the tapping purpose for that field winding. See here, बघा ही field winding आहे, याचे टर्मिनल काय केलेले आहेत, ते कनेक्शन साठी बाहेर घेतलेले आहेत. सपोज दिस field winding having a number of turns 100 आहेत. So there are 4 tapping points. That means we are, suppose it is equally divided or it may be unequal divided. So 25 number of turns, again 50 number of turns, again 75 number of turns, and again 100 number of turns. Now see, in case of a tapped field winding, suppose I am connected my machine to at initial tap. मी सपोज इनिशियल टॅपला कनेक्ट केले, म्हणजे 0 to 25 नंबर ऑफ टर्न्स ला कनेक्ट केले. Okay, so see, when it is connected to first 25 number of turns, what about if the number of turns it is nothing but 25, that means total number of turns 100 hai, we are connecting less than that of 100, that means we are connecting initially 25. What happen about the flux? Number of turns kami astil, what about flux?
कमी असते.
Flux is also less, or it may be flux is also minimum. That means at minimum value of flux 0 to 25 number of turns, 0 to 25 number of turns, if the flux is nothing but phi1, and at the phi1 value of flux, suppose we have obtaining the speed 1500 revolution per minute, right? 1500 revolution per minute ला काय करतोय मी कनेक्ट करतोय. If we are connecting 0 to 25 and we are getting the speed of 1500 revolution per minute. Now I am changing this tap and it is connected to 50. हा टॅप चेंज केला मी आणि 50 ला कनेक्ट केला. What happen if the number of turns it can be increases? What about flux?
Increases.
Flux is increases, right? No, that means we can do reverse tapping as well as forward tapping also. Suppose same condition I am telling, but reverse direction. I think you got the meaning of tapping. Tapping चा meaning तुमच्या लक्षात येत असेल. Suppose if I connect total number of turns, suppose मी 100 number of turns पहिल्यांदा काय केले कनेक्ट केले. If the total number of turns it can be connected, total number of turns it can be connected. At that situation, if the total number of turns it can be connected, suppose flux it will be produced phi1, or it may be maximum flux. If I reduce these turns to 75, बघा इथपर्यंत हे ज्यावेळेस टर्मिनल मी इथं कनेक्ट करतोय त्यावेळेस या टोटल नंबर ऑफ टर्न्स कनेक्ट असतील, राईट? बरोबर ना?
Yes, sir.
हा, इफ आय रिड्यूस दॅट व्हॅल्यू ऑफ टर्न्स, म्हणजे मी इथं कनेक्ट केलं, लाईन मध्ये किती इथून इथपर्यंतच्या टर्न्स काय राहिल्या प्रेझेंट राहिल्या. सपोज दिस टर्न्स इज नथिंग बट 75% टर्न, or it may be 70 number of turns. If 100 number of turns is there initially, it will produce flux phi1. If I reduce the number of turns, that means 75 turns, whether flux it can be reduces or increases. What about phi? Number of turns reduced झाल्या, what about phi flux?
Reduces.
Reduces. Okay, right? So flux phi it will be reduces, and if the flux phi it will be reduces, according to this equation, En is directly proportional to 1 upon phi. If the phi is reduces, the speed of the motor it will be increases, right? And याच्या reverse परत जर number of turns increase करत असेल, if we are increasing the number of turns, if number of turns of the machine it will be increases, then the flux it will be reduces. If the flux it will be reduces, then the speed of the DC series motor it will be increases, right? So see, in this method the flux is reduced and hence speed is increased by decreasing the number of turns. Number of turns decrease करून आपण काय करतो, speed increase करतोय of the series field winding. The switch yes can short circuit any part of the field winding, thus decreasing the flux and rising the speed. With full number of turns, or it may be if full turns are connected to that of field winding, the motor runs at a normal speed. ज्यावेळेस full number of turns कनेक्ट केले आहेत, म्हणजे 100 number of turns कनेक्ट केले आहेत, त्या कंडिशनला जर मोटर 1500 RPM न रन होत असेल, दॅट इज नॉर्मल स्पीड न. इफ आय कनेक्ट इट टू 75 ला कनेक्ट केलं म्हणजे मी नंबर ऑफ टर्न्स काय केलं, रिड्यूस केले. इफ द नंबर ऑफ टर्न्स इज रिड्यूसेस, flux is also reduces. If the flux is also reduces, that means speed of the motor it will be increases. Suppose speed is getting 1700 revolution per, like that. Okay, that means by decreasing the flux, कसे decrease करतो flux? By decreasing the number of turns. By connecting particular tapping, we are decreasing the number of turns. If the number of turns it will be decreases, the flux produced by that field winding it will be decreases. If the flux produced by the field winding it will be decreases, the speed of the motor it will be increases. Speed motor चं काय होईल, increase wheel, that means the rising the speed with the full turns of the field winding, the motor runs at a normal speed, and as the field turns are cut out, म्हणजे आपण field turns कमी करतोय, that means field turns are cut out, speed higher than the normal speed are achieved. That means we are increasing the speed, that means we are increasing the speed from that of normal speed. Normal speed पासून आपण speed काय करतोय, increase करतोय. Again this method it is very suitable in case of traction system. Traction system मध्ये ही जी काय मेथड आहे, so this method it is very suitable to increase the speed of train. ट्रेनचं स्पीड इन्क्रीज करण्यासाठी in the step by step for increasing the speed of the train, we are using a tapped field control technique. We are using the tapped field control technique. Okay, getting? All of you understood what is meant by tapped field control?
Yes, sir.
Yes, sir.
Okay, and this method now is also suitable in case of traction system, किंवा हे आता पण यूज करतात ट्रॅक्शन सिस्टीम मध्ये. आपल्याला जर स्पीड इन्क्रीज करत असाल, म्हणजे आपण जनरली सिरीज मोटर इट कॅन बी युज्ड इन द ट्रॅक्शन सिस्टीम. सो टू रिड्युसिंग द व्हॅल्यू ऑफ फ्लक्स वी आर अचीविंग द मोर स्पीड, and this is achieved by gradually cutting the field winding. Field winding हळूहळू कमी करून किंवा ती कट आउट करून आपण काय करतो, स्पीड इन्क्रीज करतो. Right? So this method it can be used in the traction system. So this is the related to field control technique. That means in case of field control technique, or it may be flux control technique, there are three methods. First one is nothing but field diverter, second one is nothing but armature diverter, and the third one is nothing but tapped field control. Okay, I think all of you clear these three technique under flux control technique.
Yes, sir.
Okay, and the last one point is that is armature resistance control method. Armature resistance control method. So armature resistance control method, it is the last one speed control technique of DC series motor. And after that we will conclude this second unit, that is unit number second, DC machine, or it may be DC motor. So in case of armature resistance control method, we are just connecting one of the variable resistance in a series with that of armature. आर्मेचरच्या सिरीज मध्ये आपण काय करतोय, एक व्हेरिएबल रेजिस्टन्स कनेक्ट करतोय. सी हियर इन दिस फिगर, वन ऑफ द व्हेरिएबल रेजिस्टन्स इज कनेक्टेड इन सीरीज विथ दॅट ऑफ आर्मेचर. सी, this is the series field winding, it is connected in series with that of armature. In the series with that both, we are connecting one of the variable resistance. एक variable resistance काय केलंय, connect केलंय. Okay, we are connecting one of the variable resistance which is in a series with that of field winding. Okay, now see in this method a variable resistance is directly connected in series with that of supply, which is shown in this figure, and this it will be reduces the voltage available across the armature, hence the speed falls. So see, if we are inserting some of the resistance in series with that of armature as well as field, what will happen regarding current? Initially current flowing from this is nothing but 10 ampere. I am increasing the value of this resistor. मी resistor ची value काय करतो, increase करतो. What about resistor? What about current? Decreases. And if the current taken by the machine it will be decreases, automatically the speed of the motor it will be also falls, or it may be decreases. So see, by changing the value of variable resistance, any speed below the normal speed it can be obtained, right? Any speed below the normal speed it can be obtained. Or suppose consider if we are inserting some of the resistance, initially काहीच resistance नाहीये, त्याच्या series मध्ये आपण resistance insert करतो, right? Due to that resistance inserted in series with that of field as well as armature, because both are in series, If resistance are inserted, the voltage appear across the armature, it will be reduces. If the voltage appear across the armature, that means EB, right? Voltage appear across the armature, that means EB, it will be reduces. If the EB, it will be reduces, or the back EMF of the machine, it will be reduces, then the speed of the motor, it will be false, right? According to equation, EN is directly proportional to EB. If the EB falls, the speed of the motor, it will be false. And this is the most common method employed to control the speed of DC series motor. So this method, it can be used to employ, or it can be used to employ the control of speed of DC series motor. Right now, see what happened in this case. If the armature resistance control technique, it can be used. Armature resistance control technique, it can be used. So the armature, it will carry the current. This current, it can be carried by that of resistor. बघा, जर आर्मेचर मधून 8 एम्पियर करंट फ्लो होत असेल, तर रेजिस्टन्स मधून किती करंट फ्लो होत असेल? 8 एम्पियर, right? So due to that maximum value of current flowing from that resistance, or it may be the current flowing from armature, which is same current, it will be flowing from resistance. What about copper loss? Ia square Ra. What about copper loss? Whether it is more or less? Copper loss, it is also more. That means due to that maximum current. जर शंट फील्डच्या सिरीज मध्ये जर आपण रेजिस्टन्स कनेक्ट केला असता, तर शंट फील्ड वाइंडिंग, it will carry a small current. Either it may be 1 ampere, 2 ampere, 3 ampere. But this will carry a same current as that of armature. जेवढा करंट आर्मेचर कॅरी करेल, तेवढाच करंट रेजिस्टन्स कॅरी करतोय. So that copper loss is more. Okay, that is losses is more, and due to that it gives a less efficiency. Also the speed regulation of this method, it is nothing but it is having an poor speed regulation. See, it has the armature resistance control method has an poor speed regulation. त्याचं जे काही speed regulation असेल, it has a poor speed regulation. This has no significance for the series motor because they are used in the varying speed application. It is used in the varying speed application, so it has no more significance. This loss of power in the series resistance for many application, so the series motor as not too serious since in this application. Okay, loss काय आहे? That is copper loss. It is more because we are inserting some resistance in series with that of field winding, also armature winding. If armature, it will be carry a current which is same current, it will be flowing from that resistance. Due to that same current, the loss occur across that machine, it is more. Okay, so it is having an poor regulation as well as efficiency, and the control is utilized for a large portion. Control, it can be utilized for a large portion of the time for reducing the speed under light load condition. Reducing the speed under light load condition, and is only used intermittently when the motor is carrying a full load. When the machine, it will be carrying a full load, or it will carry a full load current. At that situation, we want to control the speed in the intermediate. At that situation, we are using this technique, that is armature resistance control technique, or it may be armature resistance control method. So these are the field control technique of DC series motor. That means there are main two methods we are using to control the speed. First one is nothing but flux control, and the second one is nothing but armature resistance control. In flux control technique, we are again using three techniques. First one, field diverter. Second one is that armature diverter, and third one is that the tapped field control. That means we are providing a particular tapping. Okay, so these are the some speed control technique of DC series motor. Okay, getting
Yes,
or
sir.
is there any doubt? कोणाला काय doubt आहे का याच्यामध्ये?
No, sir.
Okay, so in this way we will conclude this today's point also, as well as we will conclude this second unit that is DC series motor, and from next lecture we will start the next unit, that is third one unit, testing of DC machine. For your just 1 minute.